Hello everyone, in this video we're going to be solving this integral, and I thought I'd show you some clever techniques commonly used to solve these types of integrals and also some useful formulas. So the first thing I'm going to do is multiply the numerator and the denominator by 1 plus sine of x. So this is equal to cosine cubed of x over 1 minus sine of x times, I'm just going to multiply it by 1 plus sine of x, which is the same thing as multiplying by 1, because anything over itself is just 1, and that doesn't change. So we can recognize that this and this actually follows a common formula from algebra. So in algebra, we know that a squared minus b squared, the difference of squares, right, is a plus b times a minus b. So it kind of looks similar to what we have, right? In this case, we have 1 plus sine of x being multiplied by 1 minus sine of x. And so in this case, our a is 1 squared, and our b is sine squared of x. And 1 squared is just 1. So this is still equal to cosine cube of x times 1 plus sine of x over 1 minus sine squared of x dx. Okay, nothing's changed. So now we should be able to recognize this from trigonometry. So in trigonometry, we're told that sine squared of x plus cosine squared of x is equal to 1. And we can move sine of x to the other side. That tells us that cosine squared of x is 1 minus sine squared of x, and that's what we have here. So I'm just gonna replace it. And now this is helpful because we can cancel out cosine squared of x by doing the division. So this is going to be equal to just cosine to the first power of x times 1 plus sine of x dx. Okay. And so from here, now we can do a standard use substitution. We recognize that sine is in here, and we also have cosine x dx, and the derivative of sine of x is cosine of x. So I'm going to let our u be sine of x, and taking the derivative of both sides, we get du is equal to cosine x dx. And that is what we have right here. So this becomes the integral. Cosine x dx is simply du. 1 stays the same, and sine of x became u. And now this looks a lot easier to solve. So we have a constant here and a variable here. And now we can use our formulas from calculus that tell us that the integral of a constant c times a differential, let's say dx, is going to be equal to c of x. We're going to use that rule. Another rule we're going to use is that the integral of x to the n is equal to x to the n plus 1 divided by n plus 1. Another formula we're going to use is the linearity principle that says if we have the integral of f of x plus g of x, then we can split them up into two different integrals. Okay, so the first thing I'm going to do is apply that concept of linearity. So now we have the integral of 1 du plus the integral of u du. And so now applying this rule over here, the left integral becomes simply u plus, and then applying this rule over here, this becomes u squared over 2 plus the constant of integration. But our answer is in terms of u, but we need to get it back in terms of x. So now what I'm going to do is undo the substitution. So u is simply sine of x, so this becomes sine of x plus sine squared of x over 2 plus our constant of integration. I hope this tutorial was helpful and you learned something. If you have any questions or feedback, please leave them in the comments, and thank you for watching.